het is best wel voor mensen is dit best wel goed. Ja, de measurement is 5 minuten geleden, of 30 minuten geleden. Dus ik denk dat we even moeten woord opleggen.
Buongiorno. Wat mijn verkeerd. Streamhouse. Ai. Ja, goed. We gaan nu live met een van de... Oh, ik ben trouwens... ik ben al live voordat ik gekke dingen zeg.
Ik ben aan het vertellen dat je...
Nee, met, ook voor jullie natuurlijk. Hè? Dus
pak maar mijn eigen portie.
met een IBM hele leuke... Mensen die bezig zijn, is er militair. Dat is wel leuk. Dus ik moet even inbellen. Hey, Martin, can you hear me? I think of course, I need to allow you to speak as well.
Hello,
Can you confirm that you're there?
Yes, do you hear me?
Yes, I hear you. Great. So just in time. So we had some challenges to get Martin in, but I think you made it with 2 seconds on the clock, right? So that's perfect. Martin, what I'm going to do is I'll do a 30-second intro, and then I'll make you the host. And once you're the host, you're in full control of the session, and that also means that I'm no longer in control. So then you can share the slides that you have. You can mute me if you like, right? Of course, I'll be in the room. And for everybody that has questions, if you're listening in, and I'm pretty sure you'll have some questions, please put them on the chat. I'll make a note of those questions. I'll record them here in my notebook, and I'll post them to Martin at the right moment, so he doesn't have to read the chat while he's speaking. But if you have a question, please put it in the chat, and I'll make a note and make sure that they will be addressed. Martin, with that, I'm going to make you the official host. So coming up now, and that should give you control over your camera, control over sharing slides. Here you go. Good to see you.
Thank you very much, Lens. Thank you very much for the kind introduction. And it was indeed like a very well-timed join that I've done here. Then I would say that I just start sharing my slides and get going.
Yeah.
You see this presentation?
Yes, looks great. Yeah.
Okay, yeah. Then thank you very much. This is the talk about generative artificial intelligence and how the next milestone in machine learning will improve the products that we built. I must say that this is a talk that I have taken certain snippets of my online course. I just on Sunday released an online course about generative artificial intelligence. So there are many things, of course, because it's a 7 hours online course. I cannot like present everything now, but I'll just give like an overview. Then I dive into one application field a bit more deeper, and and go also into the technical side of it. Exactly, first, what is the difference between discriminative AI and generative AI? Why does it matter? Where is it located within the field of artificial intelligence? From my perspective, the most important architecture are generative adversarial networks, so they deserve a chapter by themselves. Well, I will not go into depth as why it took so long, and then also what can happen, what can be wrong, and how to deal with problems while developing generative models. I've taken this out, and also like a very much code-based demonstration. I will postpone it to the online course in case you're further interested. But I will definitely go into the application field of 3D object generation, and then a little bit of an outlook, and I think then we are at the end, and I'm very happy to then answer your questions further. One slide prior to the presentation also, generative art is also part of generative artificial intelligence. It's certainly partially overlapping, and because generative art, a lot of art has been generated, especially with putting it on the blockchain and NFTs and so forth. This field has a completely new emphasis, I would say. But I just want to point out that I'm including a couple of generated art pieces along the slides. And I'm always like crediting the respective artists. So GAI, so generative artificial intelligence, GAI is quite promising, and here are just three quotes that I'm taking from IBM Research, for instance, where they say the advances are likely to increase and generative design techniques are likely to come into the core curricula of data science, creative and engineering professions globally. And this is true, yeah. In the standard data science curriculum, it is not much of a part, at least not up until recently. Then Harvard Business Review says that AI can not only boost analytics and decision-making abilities, but also heighten creativity. Yeah, so generative models, we shouldn't use generative models in order to substitute someone, but to enable or further heighten creativity. That's that point here. And Gartner has it actually put it as one of the top 12 strategic tech trends, and says that generative AI, which creates original artifacts or constructed content and data, is the next frontier. So there is a lot of attention in that direction. This is, of course, there was just some selected quotes. But what I would like to look at now is, what is the difference between discriminative AI and generative AI, or actually, what is discriminative AI and what is generative AI? And I would like to draw like a certain line here. Discriminative AI is, and let me make your picture a bit smaller here. Okay, better. Discriminative AI is, when I talk about discriminative AI, I mean more the conventional part of AI, where we are using cutting edge technology, like machine learning, to discriminate, and the common typical fields. And I'm taking it from this graph here. Perhaps you know this graph, that machine learning has supervised, unsupervised learning, and then these subfields: dimensionality reduction, clustering, classification, regression, but also reinforcement learning. And
this is not seeing the graph yet, Martin. I think you still need to.
Okay, you don't see the graph because I'm only sharing my slides, I think. Let me quickly.
It looks like I remember seeing it in the presentation, but now if you're sharing it. It was just a white slide.
Okay, so when I'm switching I actually wanted to show something in the browser. Let me quickly unshare, okay? Who can stop sharing? And now, sorry for that little inconvenience.
No worries. We've had way more challenging situations. So like maybe 2 weeks ago, I had a webinar where I, without knowing it, muted myself for 15 minutes. But that was definitely not great. So no worries.
I see. But now when I click on this link here, then it should switch, right?
Yeah, it's switching.
Okay, perfect. Yeah, so perhaps when you're working with within the field of machine learning, then perhaps you have seen that graph. It's quite a famous graph with unsupervised learning, supervised learning, and reinforcement learning, and then the respective subfields like dimensionality reduction, clustering, classification, and regression. And now going back, and these are also the subfields that I've mentioned here. And I just want to point out where the discrimination part is happening. I think in classification, it's quite obvious. We classify or we discriminate. Is it, for instance, our face unlocking the phone or not? Or is it a spam email that is coming in or not? Then we have regression, where we, for instance, try to regress a house price of a certain house with respective parameters like number of rooms, square feet, has it a balcony or not, which area it is. So multi-dimensional, and then regressing one price line. Oh, I see there is a raised hand. I can already take questions, or should we do it at the end?
Yeah, I think go ahead. I'll keep the questions, because there you can raise your hands, but you can also put stuff into the chat, and it's going to get busy soon. So ignore it for now, and I'll make sure you see it later.
Okay, so exactly. Then another part is clustering, where we try to cluster certain customer groups into its own cluster from customer data, and then perhaps do some targeted advertisements or recommendation engines. When it comes to dimensionality reduction, we discriminate which data do we actually get rid of or we take in. And this then is also closely related to compressing information. And then in the field of reinforcement learning, there's this concept between exploration and exploitation, yeah, of an agent within a virtual environment, and the agent then discriminates what path to take. Well, yeah, so it's more like a choosing. And in when we talk about generative artificial intelligence, first of all, there are three main pillars that I see. So first, it can, and that is quite obvious, maybe, that it generates data, all kinds of data. It can be image data, it can be 3D objects, text, but also video data, where it then, which actually is generating images, but in a sequence, time series, etc. So this is the first pillar. The second pillar of generative AI or generative models is where they perform all kinds of different data transformations. So a domain transform, where, for instance, we have a horse and we want to transform it into a zebra, or we want to take a day picture and make it into a night picture. Then we have a style transfer that could be an example here, where we have one picture and from I don't know, from city, and we want to transform it into different paintings, for instance, Monet or Picasso painting or ukiyo-e or something. So this is when it comes to data transformation, and this is also being utilized in different kinds of techniques for data augmentation, for instance. And the third important pillar that I see is this enriching of data sets and ultimately improving machine learning performance. So I will not go into depth here, even though it's super interesting, but in my online course, of course, where you have a very unbalanced data set, for instance, brain images, with some cancer or some rare cancer. You don't have many real cases, but then you can utilize generative models to enhance and enrich that data set and ultimately make the machine learning classifier perform better. But there are many things to take into consideration here, but from a very high level perspective speaking. Okay. Generative AI has a broad application field, and just to name a few, where already successful progress has been shown. So text to image, you put in some text, you describe a scene or maybe some object, and then this respective object has been generated. 3D object generation, that is basically where we will go in depth in a moment. Human pose generation, domain transfer, style transfer, set the high resolution image generation, so where it can really remasters images, movies, but also there are remastered games, Max Payne, etc. Already. Video generation, synthetic data generation is where we enrich data sets, clothing translation. So there are many different examples. This is just a few. Okay, and to conclude of GAI's importance, this is what I said. That Gartner has put generative AI into the top 12 strategic tech trends for 22. So it really is in the focus of many companies. Also for IBM, that is using generative AI to accelerate drug discovery. Books are being written about it, or here it's a respective chapter. That's a very good one that I usually show. And it's then also on the Gartner Hype Cycle, etc. Okay. Now we zoom out a little bit, and we take a look at where are generative models located within the realm of artificial intelligence. So if this is AI, then this is machine learning, and the difference here is that machine learning is like this. You use training data and it learns along data, as a very rough description. And the AI that is not machine learning is that could be, for instance, expert systems, where some subject matter expert has put in valuable information into a database, and then you can retrieve it, etc. So this is This is the non-learning AI. With the machine learning, we have deep learning. Yeah, this is then when it comes to convolutional neural networks or other neural networks, multi-layered, that then extract, that can solve various kinds of deeper problems such as object detection and image classification, etc. And something that overlaps all of this is then the generative artificial intelligence. So you can have learning pieces, you can have non-learning pieces, and they touch deep learning. And actually, this graph is not fully correct because you can also just have some rule-based non-AI pieces. So it should also go a little bit outside of this AI Venn bubble.
Martin, can I ask one thing in between, or actually two things, because they keep popping up? Like your course,
Yes.
it's on Udemy, right?
It is on Udemy, and I will at the end I will also show it just to make the bridge.
Yeah, great. And the slides that we have, can we share them with people? Because I think a lot of people are making notes, and there's a lot of stuff on the slides. Is that okay for you if we do it?
Absolutely, yeah.
Great. Okay, those are the two questions. So I think it changes a bit how people look at this and how much they will note and how much they can expect to get in the inbox later. Thanks.
Yes, sorry, yeah, I should have said it from the beginning. Yeah, I can share the slides and I will send it to you, and then you distribute it, right?
Yeah.
Same with the link of the course. Okay. All right. Thank you very much. Yeah, and then exactly. So from these are the self-learning algorithms, the machine learning, and the non-self-learning algorithms. Like a rough classification. I would like to very briefly, I don't want to, because I think time-wise, yeah, I have to see. I can talk about the evolution, not too much, of deep generative models. There are basically 4 pillars that are very significant. First, autoencoders. Just very briefly, what is an autoencoder? We have some input image, for instance. Yeah, this is not an example for image reconstruction. It can be for whatever example, but here that's maybe a bit more intuitive then, where we have some input image as a handwritten true, and what we want to get out at the end is a handwritten true, so that we encode it in the first half. Do you see my mouse? No? Okay. The first half, the encoder is where it takes the high dimensional image, transforms it down. This can be with convolutions, yeah, or with some other layers, and boils it down to a 2 or 3 dimensional space. So from high dimensional, yeah, pixels. So if it's 28 by 28, then it should be something, I don't know, 500. Some 500 something pixels, and they are being boiled down to 2 or 3 neurons that are representing the latent space, and they represent a distribution. Yeah, so a 2 has a different distribution among these 3 neurons than a 1 or a 3, and then in the same way, inversely, we decode it and want to go back. So this is here the latent part. And you see the output will not be exactly as the input. There will be some difference, of course, especially when we are training. And what then it is easy to do is to create or to calculate the reconstruction loss. Simply pixel by pixel, calculating the reconstruction loss. Yeah, well, how far are we away from the original? So this is a straightforward. Sort of straightforward deep learning generative model that has only a limited power to create a high quality outcome. And there is actually a deeper problem with it. It doesn't have true generative capabilities, because it's because when we are looking at the decoder of an autoencoder, that's basically the generating part. Then on the left hand side, on the code side, we would then just give them some vectors, and we want, according to the vectors that we put in, then we want to have certain outcome. And so if these are the 3 inputs, so to the generator, now you should see the mouse. These are the 3 inputs, Z1, Z2, Z3, but I take, for simplicity reasons, the Z3 away. We then, when we generate figures, these handwritten digits then you see that they are very like encapsulated in how they generate the data, and in between we have some missing. It's not well trained or well defined. It knows how to create a 1, it knows how to create a 7, but what is happening in between? So there's no true generation happening. That's how the variational autoencoder came into place, because what they introduce is an additional layer where we have a mean value and a standard deviation value and some noise vector. Putting it all in, it does not like an autoencoder just defines, it's not a direct encoding to the beginning, yeah, because it's just a direct encoding for autoencoders, but for variational autoencoders not. It introduces like a distribution around that one point. So this is the mean, and then some distribution with a standard deviation of whatever has been defined. And this, what it helps us to do, it bridges in between the gaps. Yeah, it then defines a true generative capability. Yeah, and looking at, for instance, at handwritten digits at the outcome, I hope you can see that, and it's not too small, but here are 1s, then here are some 6, here you see some 2s and 8, and they morph into each other's numbers. So you can also find this in between values. And in the middle, we have 0s and 7th, yeah, 5. So no matter where you go in the latent space, you can then generate a respective number that introduces also variations and mixtures. Looking at some arithmetic results, I will skip this part because this is more intuitive on the right-hand side, I think. So when instead of numbers, we would produce faces. So then you have a face without glasses, for instance, and a face with glasses. And then you can properly do the vector arithmetical mathematics to identify what is the vector that is the difference between them. And this defines the feature, so the glasses. And then when you have a face, you just add the respective vector, and this face has glasses. And this is interchangeable with all the different faces. And not only with glasses, you can do this with all kinds of hair and eyes, etc. So true generative capabilities. All right. And now the most important part, according, when it comes to deep generative models, and they have also introduced a huge breakthrough, are generative adversarial networks. By the way, if you have many questions, ask them later. And if we don't have the time to answer them, please feel free to contact me. And I'm happy to discuss various aspects. And maybe you have also some valuable feedback for me that and maybe some resources that I also should take a look at. So I'm very happy to go into the dialogue here. GANs, yeah, they deserve a whole chapter by themselves. GANs are very powerful. Yeah, they have many advantages. So first of all, they genuinely generate data, no plain data augmentation. GANs generate data with convincingly good results. For instance, if so, there's a paper of super resolution, and yeah, the simplification.
There are 4.
I don't know if you hear the sound or not.
Yeah, we do.
Okay. Yeah, this is this TechoGAN, which is from the Technical University of Munich, and what they have created is a TechoGAN that remasters videos in a very good way, with very high quality. So you see that there is a very low resolution video, and what the TechoGAN does is it interpolates it, on the knowledge that it has around the world. And then these are all like clickable links that you can take a look at them. Data versatility. So yeah, you can generate all kinds of data, images, text, audio, video, as I already said. The sky's the limit here. And they are powerful unsupervised learning algorithms. just quick reminder, what is unsupervised learning? So supervised is when we have labeled data. So it's much easier for a machine learning algorithm to identify how to classify something, or what belongs together, is to discriminate between the data. That's much easier. And in the unsupervised learning method, we don't have any labels, but algorithms try to identify clusters by themselves, or group them in one way or the other. So this is when it comes to unsupervised, and they are very powerful in doing so, in understanding the world. And Jan LeCun, who by the way is I would say the father of convolutional neural networks, very successful deep learning architecture, and he was the first one that described it. He describes GANs as the most interesting idea in the last 10 years in machine learning. And this is the father of GANs, this Ian Goodfellow. He's by himself, super interesting. So Stanford, Montreal with Joshua Benchio, very famous figure in the machine learning world. Google, OpenAI, then Google again. And now he is at Apple, the director of machine learning in the special projects group, and one of the Fortune 40 under 40 person. And why I'm mentioning it is because he has written a book with Joshua Benchio called Deep Learning. If you don't know it and you want to get to know more about deep learning and like really well conceptualized, I highly recommend this book. And since since he developed or proposed the paper of the first version of a generative adversarial network in 2014, it of course took a little bit of time to understand what the capabilities are and so forth. But then the number of GAN paper submissions exploded. Yeah. And this is here until like some mid 2018. And I was so free that I just checked what are the submissions for further years. So 2019, 2020, it's 3,700 additionally. 2021, it's 5,185, and then 7,000. So the exponential growth continues. And what I basically want to say is it's a super hot topic. GANs are still super hot, and I think there is so much more to do.
And Martin, why do you think it took 2 full years before it took off? Because actually that beginning for me is also interesting.
Yeah. So this is a good point. Yeah? But it would be surprising to me if immediately it would explode. I read the paper. It is not, not straightforwardly written, and it's not about like what the potential, what can be done with it. I think the research field and the companies, they needed some time to understand where do they actually provide value and experiment a little with these architectures, because GANs are really, really hard to train if you do it from scratch. Why, I will show in a moment. But I think it has something to do with that. But it's a good question. It really took some time. But the direction is clear, I think. So how does a GAN work? Quickly, I'm okay, 28, so I have to hurry up a little bit. In the online course, by the way, I'm going much more in depth, and I'm also not implementing. I'm not going through all the implementation, like how to set up the libraries and how to set up the indices. These are all things that can be answered with Stack Overflow, or it's just one Google away. Where I will really focus in the online courses on the key parts a generative model should have to quickly get the ball running. So, and in the same way here, I look at the crucial parts. So, of course, it should have a generator part where you give it a latent variable. Then whatever the generator is, that can be a deconvolutional neural network. I show that in a moment. And then this generator produces some sample. Yeah, that's the synthetic data. In comparison to that, we also have real world images samples. And we give both of them to the discriminator, who then has to decide, is it real or fake data that I'm getting here? That's the only job, is it real or fake? So fake or real. And then, you know, we know the answer because we know which data comes from the generator, which data is real. And we calculate a loss out of this and train the generator separately, and we train the discriminator separately. This is important to know. And here's also where the difficulty comes in, because while the generator tries to fool the discriminator tries to not to get fooled. So they have to learn adversarial to each other. That's why the name, generative adversarial network. So as they are learning adversarially, they need to be equally strong. Yeah. So and as they are also learning independently, it's really, really hard to keep them equally strong. It's quite easy that the generator is getting a little bit faster to good results, so that he quickly figures out how to fool the discriminator in a way that the discriminator always thinks, oh, it's real. Yeah, and vice versa. The discriminator can get so good that he always knows when it's synthetic data he's getting to. Yeah. And from both we cannot learn. There's like no difference in the outcome, and so it poses a lot of it poses a couple of problems. In my course I list them, and then also how to mitigate these issues. So it's this interplay between generator and the discriminator, and the discriminator can be a convolutional neural network, yeah, that evaluates the candidates. It gets here, it's a dog image, and it then convolves it until there is at the end a final decision, real or fake. And on the other hand, we have a deconvolutional neural network, which builds the candidates. That's the generator, and it can be more or less the inverse operation of the convolutional neural network. Yeah, the deconvolution, of course, and then we have, instead of a pooling, we have an unpooling. But this is I don't want to like go too deep into this here now, because there's still a little bit of content I would like to show. Yeah. Oh, by the way, this, because it's a convolutional neural network and a deconvolutional neural network, we talk about a deep convolutional GAN. All right, and what GANs do exist? And this is then basically the fourth pillar that I would like to show. There was this GAN zoo only until 2018, because then the number of architectures exploded. But here are many different GANs, and also respective papers linked. And 3D GAN is what we will take a look at in a moment. And the community is also quite open. So yeah, you can basically take it and yeah, and use it for your own projects very quickly. And also archive. When you look on archive, there's so many architectures that I've shown already. For instance, just the first one, it's a PetroGAN. Yeah, it's a very new architecture. And what this one does, I have actually read that paper today. It generates realistic, label-free petrographic data sets. And petrographic is like stones with petroleum inside, and that store petroleum in their cavities. And these are certain images. And this PetroGAN can generate these images. Super interesting application field. And I think when you take this idea, you have to generate a very specific data set with a specific GAN. I think the amount of application is infinite. And this is also actually a point that I would like to make in the online course. We take many applications, and then we just brainstorm what could be created out of this, and where to take data sets from, and how to build quickly something that can generate completely new value. Yeah. Okay. Application fields. There are many application fields, of course, but I would like to go into the 3D object generation, because I'm very much intrigued by this field. What we do here is, we have a generator that is a volumetric convolutional network. Instead of a convolutional neural network, it's a volumetric convolutional neural network. It takes some input, and it then unfolds it into a 3D voxel space, yeah, with convolutions. And what we at the end, what we have is a 3D voxel space, for instance, 64 by 64 by 64, a cube. And this is our generator, yeah. And in the beginning, it will be very noisy, what will be created in this cube, yeah. But what we want to have is something like an object, a chair that makes sense to us. So we need to train it in the training phase with respective training data. And the training data, it can look like this, yeah. That we have a generator, we generate some shapes, as I said in the beginning, noise, really garbage, yeah. Cannot do anything with that, but we also have, we need to have a proper data set. We need to have real shapes, measured dimensions of an object. Chairs are just an example, yeah? It can be whatever. And then again, this is the real data and the synthetic data, and we give it to the discriminator, who then has to decide fake or real, and then we train again. Yeah. And this is actually, these are the first results from the Stanford University. They have generated chairs, sofas, what else, tables, cars, and you see it's very high with a lot of pixels, or like big pixels. This is already, I think, 4 years ago, and something has happened in between. So, but the interesting point here is you can interpolate between these objects. You can interpolate between this chair with armrests to this chair without armrests, and stop at the moment where you think, okay, this is fine now. You can also extrapolate between objects, yeah, from a car to a boat, and then say, okay, this is an interesting hybrid version of something, yeah. And it's all happening in the latent space, yeah. You can also do these arithmetics that I've shown earlier with the glasses and the face. You can add armrests, you can subtract features, you can add some other objects, and then you have something at the end. With chairs, the same, yeah. And this is basically this was a big breakthrough, and when it comes to object generation and coming up with new products, new shapes, and this opens up a complete field, yeah. And this is 4 years ago. Now we go a little bit further down the research line, because many things have happened since then. For instance, this interactive drawing here, where someone draws a chair just from that sketch. Yeah, it's called Pix2Vox. And to us, it's clear, okay, now this could be a chair, even though many features are missing. Yeah, there are legs missing. Here's just a line, it's not even finished. And the GAN in the back already, the 3D GAN knows already, okay, this is a chair, and it's supposed to look like this, and it can build out of that, yeah. Well, that was also quite interesting. Let me go a little bit further. Also, again, here, all the links if you want to read. Pix2Vox ++, that's, again, a little bit further. What they have done is they take a picture, just a picture, and they try to reconstruct this. They have the ground truth, and then they also have done like a comparison with many. I'll cut them out, the other ones, because I want to just be with the Pix2Vox model. And they know what the ground truth is. So these are measured objects. And then the respective Pix2Vox ++ model, there are two different models. One is a bit smaller, one a bit bigger. The A is 10 times bigger as the F. So the 10 times bigger one is already producing really good results. And this is not so, it's not so pixelated as already from before. But this has been even taken even further. Let me click on this repo, where it has a silly name, not silly, but it has like a not very intuitive name, let's say. Multi-view silhouette and depth decomposition for high resolution 3D object representation. And what it, for instance, does, you give it an image like this. So it's some Eurofighter jet. And we know how these objects should look like. So we could maybe model it from our world understanding. but this model is trained so well that it can, just out of this picture, it can create a very high resolution jet, basically. And I think, yeah, this is already three years ago, and you know, there's much more to come, or maybe there is much more, but I haven't seen it publicly available. But it's great progress that can be utilized for our own projects. Yeah, this is basically it to 3D object generation. 40 minutes now, so I finished.
Sorry, Martin, I think it's fascinating. So don't worry too much about the time.
Okay.
And maybe for everybody listening, if you have an urgent question, because I have a whole list for you, Martin, but I can also call you afterwards. So for people, if you have a very urgent question, put it on the chat. And otherwise, Martin, just keep going, because it's fascinating, and I don't want to interrupt you too much.
Okay, thank you very much. But it's anyways, like I have planned maybe 3 more minutes. Yeah, so exactly. So this 3D GANs super powerful and can be utilized. In fact, yeah, I'm also like, because I'm a data scientist at IBM, and we have some clients where this is relevant. So it also already has industry relevancy, of course, confidential. But the point that I want to make here is that companies are picking up on this and using it. One interesting part is also interactive image generation. And now I just fly over the topics that what else could be interesting. Yeah, face generation. Then we talk especially about style GANs and style GAN version 3, which is alias free. But maybe a quick demo on the faces here. What this page does. What was its name? Which face is real.com exactly. What it does is it creates, with the style GAN version 2, it creates a face, and then the page asks you which face is real, and maybe you can ask this for yourself, or you can try to answer that for yourself. Is this the real face, or is this the real face? And yeah, I'll just answer it. I think it's this one. Click on it, and yes, that was correct. The reason why I've chosen this one is because the background, I know how the style GAN version 2 works, and it doesn't pay attention to what's happening in the background too much. And for me, this could make sense here. Here I see just plain gray. Also, here are some artifacts that are making me skeptical. One more time. Okay, which face is real, which one not? Yeah, I think I know. I think this face is real. Yeah, it's this one, because I see some kind of artifact here. It's some blob shaped, which is for the style GAN version 2 actually quite known. It's part of a texture sticking, but I don't want to go into depth. Again, online course. But yeah, these artifacts, they have taken care of it. The research team in the style GAN version 3. Yeah, and then also in these chapters I usually discuss pros and cons, because face generation and deep fakes go sort of hand in hand. Yeah, that this is a danger that can occur. Video to video translation is also has also a lot of potential. I think, however, I haven't seen too much of applications yet, but maybe you know about this one. Everybody Can Dance is the paper called, where you have a professional dancer. She has from her we have extracted her pose, yeah, how she's dancing, and we have overlaid that pose, not we, the in this paper, and they have overlaid the pose onto the researchers' dancing video, and it looks definitely fun. Check out when you're clicking on this link. Art, of course, I said that already. This is also a big piece, and maybe here's one question for you. This is the first artificial or generated art by a GAN with that optimization function. And maybe you can ask yourself, like, how much was this for how much was this being sold? Yeah, I can tell you it's for 438,000. That was the very first one. And keep in mind, one more click, one more application, and one more time we would use that already trained generator, and it would create something very similar. Yeah, so it's just a click away to create new pieces. Yeah, so
that's 438,000, Martin, for an NFT nowadays is not that much, right?
I know it's nothing. I know we are talking millions with the Bored Apes and Puck, what he has done and stuff. Yeah, and people. I'm actually also like mentioning the NFT market here. This it's super interesting what's happened. You're right, Rens. Data augmentation, yeah, when it comes to cancer, like balancing out data sets is a very interesting topic. GAI concerns, I mentioned already, deep fakes, etc. That data can be misused. That is definitely something to be aware of, and yeah, maybe to give some guidance. I talk about noteworthy GAN architectures. There are many, and maybe one last thing that I would like to, because this really blew my mind. Yeah. The very last example. So NVIDIA has created this game GAN, and what the guy sent Dex, perhaps you know him, what he has done. I want to show you in the video, and I let him talk for 40 seconds.
What's it like to learn something?
Okay. This is advertisement. All right.
Welcome everybody to GAN Theft Auto. What you see here is me playing inside of a neural network's environment. This neural network was trained by watching a bot play Grand Theft Auto 5 on this particular stretch of highway, learning how to generate new frames from previous frames and player input. So every pixel you see here is generated from a neural network while I play. While generating the visuals or just improving them is interesting too, and there has been some interesting work lately with neural networks improving the visuals with Grand Theft Auto 5 in particular in attempts to make it look more photorealistic. This is something much more than that. The neural network in this case is the entire game.
Okay, I think yeah, it's definitely an interesting video that I recommend to take a look at. But just to keep that in mind, it's one trained neural network that has the entire game. Every single pixel is simulated in this neural network, and it's extremely interesting to me, at least. Okay, of course, text generation. There is a GPT-3. Plenty of application fields. You can paste in. I've done it here. You can paste in some text, and then it, for instance, you make it shorter, and what the outcome of this is NFTs are digital assets that can be traded and sold on digital markets. Then it asks, what is the blockchain? So in short, it really dances it down nicely, and then you can translate it, of course, and stuff. Like there are many different applications, and here also the results are very stunning. All right. Final plot. This is my online course, Generative AI. I named it From Big Picture to Idea to Implementation. I'm not sure if I keep it. Maybe I change the phrasing, but what you will learn in this around 7 hours course is how to implement generative AI models, get to know the broad spectrum of all the GAI applications, we want to keep it as tangible as possible. How to identify great ideas in the GAI space, and how to augment your data set. This is a focus area, and learn also about the ethical side, yeah, and definitely the technical side, yeah, from the evolution to interplay, discriminator, generator, etc. And this is the link here on the bottom below that I will send to you, Rens. And with this, I thank you very much for your attention, and very much feel free to connect with me on LinkedIn.
Great, Martin. It was fascinating. And I think I speak on behalf of everybody also in the chat, what I've seen. I think we've had at least 20 requests for your slides. So that's also a compliment for your slide making abilities. So those will be coming very soon. And at least in chemo, you convinced 2 people. I'm one of them to start your course. So and I think I have a head of growth here in the office who's still doubting if he can handle it, but he's also very curious to sign up. So that's yeah, fascinating topic. Hey, a couple of questions, and there's a lot of stuff to cover, and we have 10 minutes, so I'll try to sort of make it be to the point with the questions. The business cases that you've mentioned, is there one particular business case now, without naming clients and by staying confidential, of course, but is there one particular business case that you feel, hey, this is a very interesting one now that you may be seeing in the next few years?
Yeah. So you're referencing what I said with our clients, right? Mm-hmm. Yeah. So what I'm seeing happening is something in the field of packaging, personalized packaging. For instance, when it comes to packaging where let's say there's the theme of Easter now coming up soon. So maybe some Easter bunny theme of personalized pictures, and to create that personalization with the end customer. This is where this model have an application. Another thing is coming to designing objects. For instance, I don't name any names, right? But shoe generation when it comes to shapes and colors, yeah, and the patterns. This is where generative models play a crucial role. First in the pattern generation, and then also in the shape generation, talking to the 3D object generation, yeah. So yeah, this can be utilized in this way.
Yeah, makes a lot of sense. Okay, great. Hey, someone asked, how do GANs work in drug discovery? You mentioned it, but is that how would that work in practice? What is the logic behind it?
I'm sorry, like how GANs work in
drug discovery. So discovery of new drugs.
In drug discovery. Okay. Yeah. In drug discovery, this is not why I focus too much on it, but how it basically works is that you have like a database of, first of all, what are the effects of a drug versus what is the chemical components, and then it, as it has true generative capabilities, it takes these single features of these chemical components and puts them together in a way that potentially new effects could be generated or composed in higher dimensionally speaking. But I don't know it in great detail. What I know, because my company also has worked on that, is that it's not to substitute any chemists. It's really to give them many different options of how to compose certain medication.
Yeah. Okay. Makes sense.
But I would refer to the resources more than to myself, because I didn't have too much touch points with that.
Great. Clear. Hey, a simple question that came up a few times is hardware, right? So seeing those models, it looks like you need quite significant hardware. Some people mentioned NVIDIA 800 chips. So what is the reality there? How much hardware? What kind of compute do you need to do this?
Mm-hmm. Yeah, it's often quite a individual case. But so when you want to generate images, then you need definitely more, and the GPUs are always recommended for that. So if you try to train a generative model, a GAN that is maybe generating some images, like these handwritten digits, for instance, then purely on a laptop without any GPU, this is almost impossible. But then when you do, for instance, a style transfer, that is not so computationally intensive. I've shown these like 4 pillars. We have to distinguish like a variational autoencoder where you do a style transfer. You have like, you can train the variational autoencoder. That takes a little bit, but it's not so heavy, yeah, on images, because you take the reconstruction error. It's quite easy. Update the weights. Depends, of course, on the size. Yeah, always. It's very depending on pretty much many things. But then once you have like the model trained to then really perform the style transfer, or the generation itself is then not much. Yeah, it can be done within a couple of milliseconds to generate something or to transfer styles. But yeah, I would definitely do it in the cloud with
some GPUs. Yeah. There's a question on the risks of all this, and Kaya just asked that, do you think generative AI is a threat to human beings in the future? It scares me a little. And what are your thoughts there?
I mean, I see where the thought is coming from. Yeah, we have seen that harm has been done also with deepfakes. This is a fact. So I know that in California, that there are laws out there already that directly tackle the problem of deepfakes. Yeah, I think if we have to see it as like an enhancing of our capabilities versus versus a substitution. This is I think a very crucial point. I used to work in a design agency as a data scientist, and I was already there vocal, like it's 3-4 years ago, and I was already quite vocal about generative artificial intelligence. And what we have done there is, so they were designing, let's say, some digital products. And as they were designing digital products, what we have done with the data science team is to suggest different kinds of design options as suggestions, and then the designer could choose some of these design options and then further iterate on, because whatever is being suggested, that's not the final outcome. Yeah? So enhancing the capabilities, enhancing the spectrum of design options, for instance. I think it's how we should look at it. Yeah.
Yeah. So as a human being, you would still have the freedom to choose, but you would have more. The creative process would be sped up, right? With more options on the table.
Yeah. Exactly.
Yeah. Last one that I have here, and then Martin, my last question is going to be after this. And any final words, any things you want to tell everybody listening? But there's still one simpler question. What are the libraries used most in training GANs? Any particular ones that you like?
Libraries. So I like to set up. So when I do coding libraries, yeah. When I like to set it up in PyCharm, or TensorFlow also works quite nice. Actually, I think the examples are mostly in TensorFlow, Keras TensorFlow, yeah. Regarding Python. What is interesting is the data sets, yeah, on what data sets you train. And there is also a data set search engine from Google. Yeah, if you can just search, you can just Google data set search engine from Google, and then you'll find it. And there you just then type in what data set you're looking for. Yeah, for instance, t-shirts, fashion t-shirts or something, I don't know, and then you see already plenty of different data sets. Yeah, and libraries, as I said.
Yeah, clear. Many thank you notes. It's ending too soon. Really glad to be here, etc. I think with that, Martin, any final words? Any last things you did not address before that we should know?
No, first of all, thank you very much for having me here. Thank you, Renz, for the opportunity. I highly appreciate it very, very much. If you decide to take my online course, you can also let me know, and I can I think I can. I'm not sure what my possibilities are, truth be told, but I can probably give you some discount, I hope. And if you decide to take it and you have some feedback for me, I'm highly open for the feedback. I really want to make it a great course, and it will grow also over the time, and I will add further videos. So yeah, every feedback appreciated.
Great. You have my feedback coming, Martin, for sure.
Thank you.
Great. Hey, thanks so much for being here. 1 minute on the clock, so perfect timing. Much appreciated also from our side. Thanks, and I hope to see you soon, Martin.
Okay, thank you very much.